Accident alert system. Here in this project, we are going to build an Arduino-based vehicle accident alert system using GPS, GSM, and tilt sensor. Tilt sensor detects the sudden change in the axis of vehicle, and GSM module sends the alert message on your mobile phone with the location of the accident. Location of accident is sent in the form of Google Map link, derived from the latitude and longitude from GPS module. Here is the connection diagram of this project. SIM900 GSM module has 4 main pins: VCC, ground, RX, and TX. VCC pin is connected with the 5-volt pin of Arduino, and ground pin is connected with the ground pin of Arduino. TX pin will transmit the data to the Arduino, so it will be connected with the RX pin of Arduino. RX pin will receive the data from Arduino, so it will be connected with the TX pin of Arduino. Neo 6M GPS module has 3 main pins: VCC, ground, and TX. VCC pin is connected with the 5-volt pin of Arduino, and ground pin is connected with the ground pin of Arduino. TX pin of Neo 6M GPS module will transmit the data to the Arduino, so it will be connected with the RX pin of Arduino. We are using pin number 2 as another RX pin, so we will connect TX pin of GPS module with pin number 2 of Arduino. MPU 6050 tilt sensor has 4 main pins: VCC, ground, SCL, and SDA. SCL pin is connected with pin A5 of Arduino. SDA pin is connected with pin A4 of Arduino. This is the code of our project. To use the MPU 6050 tilt sensor module, we will include its library in the program. To include the library, we will write #include Adafruit MPU6050.h. MPU6050 tilt sensor module works on I2C protocol, so we will include the I2C library in the program. To include the library, we will write #include wire.h. To use the GPS module, we will include its library in the program. To include the library, we will write #include tinygps.h. TX pin of Neo 6M GPS module will transmit the data to the Arduino, so it will be connected with the RX pin of Arduino. We are using pin number 2 as another RX pin, so we will connect TX pin of GPS module with pin number 2 of Arduino. Now we will declare some variables, which will be used inside our program. Encode data read from GPS while data is available on serial port. Encode basically is used to pass the string received by the GPS, and to store it in a buffer so that information can be extracted from it. Void setup is a function in which we initialize the serial communication. Now we will initialize the MPU 6050 tilt sensor module. Program will not work until the sensor is initialized. 9600 is the speed of data communication. Data will transmit between GSM module and Arduino with the speed of 9600 bits per second. Serial.print 80 plus CMGF equal to 1. This command will turn on the text mode in GSM module. Serial.print 80 plus CNMI equal to 2, 0, 0, 0. This GSM command will automatically read the received message. Void loop. This function will run over and over again forever, so whatever we have written inside it will repeat forever. Now we will take the reading of tilt sensor. If reading is out of range, then Arduino will send the alert message with location to a registered mobile number. These are the variables and inbuilt functions used to extract the latitude and longitude from the received data from the GPS module. If received location from GPS is not valid, then no SMS will be sent. If location is valid, then Arduino will send the SMS. 80 plus CMGS equal to mobile number /r. This command will save the receiver's mobile number. Serial.print http maps google.com. Serial.print val, 6. Serial.print val, 6. These 3 lines will create a link for Google Map. Serial.println character 26. This command will send the message on the given number. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Our code has been uploaded to the hardware successfully. Now we will assemble our hardware. Connect the red, black, and orange wire with the VCC, ground, and TX pin of Neo 6M GPS module. Connect the red wire of Neo 6M GPS module with the 5V pin, black wire with the ground pin of Arduino. Connect the orange wire with pin number 2 of Arduino. Connect the red, black, green, and yellow wire with the VCC, ground, TX, and RX pin of SIM900 GSM module. Connect the red wire of SIM900 GSM module with the 5V pin, black wire with the ground pin of Arduino. Connect the green wire with the RX pin, and yellow wire with TX pin of Arduino. Connect the red, black, purple, and white wire with the VCC, ground, SCL, and STA pin of MPU6050 module. Connect the red wire of MPU6050 module with the 5V pin, black wire with the ground pin of Arduino. Connect the purple wire with the A5 pin, and white wire with A4 pin of Arduino. Now we will power up our project and test its functionality. After getting registered on the network, GSM module is ready to send and receive the SMS. When any accident will occur, then vehicle will tilt in any direction. So when we tilt our system, then Arduino will send a SMS on the registered mobile number. We have received the SMS with accident location. We can open this location on Google Map. Our project is working as expected. I hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.